Now, every time I record, the camera zooms back somehow, or Zoom does something. So let me just, come on, Cam. Okay, everything should be nice and clear. It's a pretty good camera. Okay. So you go to your Canvas page, read announcements. Okay, got a welcome announcement. The welcome announcement tells you several things, but at the end of the announcement tells you to enroll in My Open Math. Okay, I don't think everybody's done that yet, but some of you have. I think there were 4 people. Maybe that was in pre-calculus. I don't know. But you need to do that because that's where most of your online homework is going to be. Okay. So follow the instructions in My Open Math. Now I'll probably sit down and let you all stand behind me and I'll kind of show you how it works. I won't be able to do that in my pre-calculus class because too many people. They all got behind me, they'd have to pile up to the ceiling. I think I've got 24 people in that class. I've only got 24 chairs. Okay. How many of you are in my class? And some of you, anybody in a 7-week class? Anybody doesn't know which class they're in? There are other sections. So, what we do here won't be keyed to my class or anybody else's class. It'll be keyed to the subject matter and goals. I'll say more about that. Okay, anyhow, get into My Open Math. Okay, there's an introduction to My Open Math. If you start reading at the top of the My Open Math page, you'll pretty quickly get to the instruction to do the introduction to My Open Math. Almost nobody needs any help finding that or understanding what to do. But if you do need help, come find me if I'm around. I might be in class or I might not be available. Or go to the MARC. Everybody know what the MARC is? Some of you don't look like you do, okay? It's the Moose Academic Resources Center. It's in the library, okay? You just go past the desk in the library and there's some glass partitions. Behind that partitions is the MARC, the Moose Academic Resources Center. They have tutors, they have people who can help you, okay? So you just go there and ask them, hey, take your device, or I think they have computers, it's not absolutely necessary. I'm having trouble understanding what to do here. It's pretty obvious. I don't think anybody's going to have any trouble, but if you do, that's the way to do it, okay? It's really easy to use. There's an ABC exercise, and that's going to be due tomorrow, I think. And then this is my notes from the MDE 60 class, which is the intermediate algebra class. Okay. So this part of the note, I assume you know how to deal with fractions, although there will be an assignment on fractions even in this course. Because I assume you know how to do it, but I know darn well that most people don't. Okay, and it's going to be very important for the algebra of some of the stuff that occurs around mid-October. Okay, and then read the syllabus in Canvas. There's a link. You open Canvas and there's a bunch of things down the left-hand side, and what you have doesn't look like exactly what I have. But one of them's announcements, and right below that is syllabus. Okay. We won't be using Canvas a whole lot in this course. I won't post grades to Canvas because the only way you can get something graded in Canvas is to put the assignment through Canvas, which is a royal hassle for everybody. Okay. Assignments are usually in My Open Math, and that's where grading goes. So you go to My Open Math, you see things, you see grade book, you see the calendar, and so forth. I do recommend calendar, something that probably should have mentioned yesterday, but I showed it because I think they understand it still. Roll them out the map, follow the instructions. Also, you have a calendar. Grade book. Those are the two main things. And there's a little banner across the top says calendar, grade book, home, other stuff. Okay. So it's easy to use. Again, read the syllabus for next time, but I want to tell you the things people usually want to know, and I'll answer any questions here in a minute. Turn the recording off. Let you assault me with your questions. Okay. There'll be tests, and the most important tests are the midterm and the final exam. They'll determine. That's one way of determining whether you pass this course or not. Okay. The other way of determining whether you pass this course or not is to pass your pre-calculus course. If you pass your pre-calculus course, you're going to pass this course automatically. Even if you don't do much work in here. There's a lot of work to do here. If you do the work, it's going to make your pre-calculus course easier, so everything's going to go faster for you in pre-calculus. Okay. And also, if you do your work in here, you're much more likely to learn enough to pass pre-calculus and hopefully to do quite well. I've had people in here that make A's in pre-calculus. Also had people in here, majority of people, unfortunately, don't make it through this course or pre-calculus. Okay. So you really need to get used to the idea. You're going to have to spend a lot of hours in your math. Now, if it turns out that you have this hidden IQ of 180, probably won't have to spend that many hours in this course. I actually know somebody with IQ over 180. I think it's measured 196. I think he's going to be a dealer at the casino. Really guy. That's unbelievable. Okay, anyhow. He can pretty much take any undergraduate math course, give him a textbook in 10 hours. It's amazing. So some people work, my point is some people work a lot faster than others. You know, you're going to have to work at whatever speed gets you through the course. Okay. Now, it is possible to pass this course and not pass pre-calculus. Okay. Now, if you pass this course and don't pass pre-calculus, then you're going to want to repeat pre-calculus. Okay. But you won't have to take this course if you pass it. Make sense? Okay. I can't tell you. I mean, you have a midterm and a final exam. Midterm, okay, your homework counts about 20% of your grade. Okay. After that, it's midterm and final exam. Okay. And the final exam counts twice as much as the midterm. So you can work out the arithmetic. 1/3 of 80%. It's the 80% that's left over after the 20% that goes from your homework is going to be the midterm. Okay. What's 1/3 of 80? I think it's 26 2/3. Okay. Now at 53 1/3% is your final exam. I've never actually worked that out. I just did that in my head. So if I'm wrong, you work it out. Take your calculator. Okay. Pretty sure I was. To check that, I just add 26 2/3 to 53 1/3, and by darn, I get 80. So I'm pretty sure it's right. Now, what I just said, one of the biggest things you can do to be successful in this course is check your work. Okay. And pretty much every day when you come in here, there's going to be a quiz. And I want you to check your work on the quiz. Give you ample time to do the quiz because I want to see your work. I want to see it done on paper. Okay. So you'll prepare by doing your homework. You come in here and you'll have a quiz over what I ask you to do. In general, the quiz, we're not going to use calculators. We're not going to use a computer. We're going to write it out because that's the way you learn mathematics. You don't learn mathematics, for example, by letting Chegg do your homework for you. And a lot of people do. It's guaranteed failure. Unless you have that at 180 IQ, okay? Or high IQ. Some people are smart enough that they just look at what Chegg tells them, say, oh yeah, okay, I understand that. And they will. A lot of people say, okay, I understand that. Yeah, they're not even close. They just recognize a few words and think they understand the process. Okay? So you can't learn unless you have a very high IQ by doing anything but writing stuff out. And I recommend that you don't sit there with a calculator and computer software and stuff like that, algebra software, and think you're doing your homework because your homework has to be working. Okay. Okay. There's a bunch of other stuff in the syllabus, mostly about what to do if your instructor turns into a terrorist and starts shooting at you or something. That's not going to happen. I don't even own a gun because I don't trust my wife. Okay. The unlikely scenarios. What scenarios you have to be prepared for? Like basically there's a shooter, we close the door, pick up something heavy to throw. And get over against that wall because it's harder. Okay. So yeah, I know what to do to maximize chances of surviving. Okay. But you can read, various procedures and so forth. Some of them are in the HCC policy manual and so forth. So stuff like that. What to do in terms of, in the event of a college-wide emergency, which might just be we had a really bad storm, tore the roof off the building, we have to close the college. Okay. It's much more likely than a shooter. Okay. Okay. Not thinking of anything else right off the top of my head, but read the syllabus. I'll have a printed copy for you next time and we'll go through it. There's some objectives in there. I want you to read them just to get a picture of what you are likely to learn, what you're supposed to learn, even if you don't know what all of it means. I also recommend that you kind of read that list, and periodically as you go through the course every week or two, so you can kind of gauge your progress. Yeah, geez, I didn't used to know what that meant, and now I do. Fair enough? Okay. I'm going to let you answer questions as soon as I get my record. Okay. Okay, so a few problems for you to work out. We'll start over here, because that way if I write backwards, I don't block the board. People on this side of the room, at least not as much. Okay, so let's just start with I want you to not just write down the answer. I want you to write down the steps as best you can understand them. I think most people get the answer to this pretty quickly. But if you understand what the steps are, please include them. And actually, we'll work through these after you do. Never walk in front of the camera.
Okay, I'm sorry.
No problem. You didn't know that. So I'm gonna, it's a privacy thing. So if you come in late, walk around the campus. Everybody can remember that. And don't talk. Although naturally you did because I was talking to you.
Yes.
Right? So you didn't do anything wrong. But just, I don't remember those things. Also, I just went over a bunch of stuff, just about the course and what you need to do. You're gonna need to look at the video. Okay, and it'll be posted later today. It soon behaves itself.
All right, sounds good.
Okay. Okay, so grab a piece of scrap, you've already got one. See, that's good. Tell everything. Okay. Grab a piece of paper and just work this out. Show me the steps if you know what the steps are. I think everybody pretty much knows what the answer is. And then two-thirds times 5. And then what's 3/5 plus 2/3? That's a little harder. So just kind of gauging where you are with fractions, because we're going to be doing a lot of stuff with fractional expressions with symbols. If you don't know the rules for the numbers, you're not going to know the rules for the symbols. Okay. And then exponents is another kind of big deal. So, let's order the thirds. What's x squared y to the third? X squared y times x cubed y squared. What's 2 to the negative third? What's x to the negative third times x to the third? What's x times y squared plus y cubed? A plus b quantity times the quantity 2a minus 3b. A plus b squared. And can you factor? X squared plus 5x plus 6. Okay. So what do we mean by 2/3 plus 5/3? Okay. 2/3. Take a piece of scrap paper, tear it into 3 pieces. 2 of those pieces will be 2/3 of a piece. I think everybody understands that. But now we need 5/3. So we tear another piece. We get 3 pieces. Well, we add that to the 1, we've got 4/3. So we got 2/3 and 4/3. We got to sacrifice another piece of paper, tear it in 3 pieces, take one of the pieces, add it to the 4/3, we'd have 5/3, right? That's what fractions mean. And not a set of rules that you do not something you do with computer algebra systems, not something you do with your calculator, something you understand. Okay? And that's all there is to understanding fractions with the same denominator. Okay? So if we add those 2/3 and those 5/3, how many do we have? We have 8/3, right? 7/3. So I'm still incorrect. Okay, so 2/3 and 5/3 is 8/3. And the rule for adding fractions with the same denominator is we just add the numerators, because that tells me how many thirds I've got here and how many thirds I've got here. Okay. I wrote it down that way. What I do when I, okay, you gotta keep an eye on it. I just pretended to write that wrong. So you'd be aware that you need to keep an eye on it. Okay. Fair enough. Okay, don't hesitate to correct me. I love to be corrected. Okay. Now, what do we do with 2/3 times 5/3? Well, I could talk about that ripping paper. It gets a little complicated. Okay. So we're not going to make it as obvious as it is here. But the rule is we multiply the numerators and multiply the denominators. Okay. So that gives us 2 times 5, 3 times 3, which is 10/9. Now, not everybody got that, but if you showed me your steps, I get a little bit of insight into what I need to say to help you correct it, okay? So that's one reason we always show the steps. Another reason we always show steps is because that reinforces what we learn. We don't show the steps, we just do it by habit. We start losing track of why we're doing it. And that's not the best way to learn mathematics, although sometimes, you know, if you got a test tomorrow, you're gonna develop a habit and use it, and then try to make something of it, okay? Okay, so now how about 3/5 plus 2/3? Well, I can rip a piece of paper into 5 pieces, take 3 of them, right? And I could rip paper into 3 pieces and take 2 of them and put those together. What in the world? I get choked up when I talk about this. First couple of days in class, I haven't been talking that much. So whatever's in my sinuses tends to end up in my vocal cords, the vibrations. Okay. Anyhow, and I get hoarse. As soon as I walk on campus, I get hoarse. Difference in the air, I don't know. That goes away after a while. 3/5 and 2/3. Okay. So we've got, you know, 3 of these pieces and 2 of these pieces. How do we put them together? Well, it's a little complicated. What we do is we say, well, okay, I don't know how to figure out how many what's I have there. So we rewrite these expressions. We want to have the same denominator. If we have the same denominator, then we can rip both pieces up into that number and count them. Of course, we've got rules we follow, but we have to understand that that's what we're actually doing. Okay, so 3/5. If I multiply 3/5 by 3/3, it's going to give me 9/15. Well, 9/15 is identical to 3/5. It just looks a little different. Okay. So if I take my 2/3 and multiply it by 5/5, nope, yep. You ever lose your thought before you finish? Okay. Then we get, I'm going to get a little crowded here. try to write it as clearly as possible. Okay, look at what we've got. We've got 15 in both denominators. So we break the paper up into 15 pieces, 9 of them will be our 3/5. And 10 of them will be our 2/3. And they'll add up to 19/15. So I kind of recommend you try to understand addition of fractions on that level. Multiplication is easy, you just multiply numerators, multiply denominators. Again, I'm not going to try to explain why that works, because it's a little bit more complicated. And you're less likely to understand it. This you should be able to understand. And if you understand it, then you know what the rules are. So when you see something like this, you'll have a better idea of what to do. You're going to have to get a common denominator. You're going to have to multiply this by x. You have an xy. You're going to have to multiply this by 3y. So you multiply numerator and denominator by the same number. You can do that because 3/3 is just 1. That's just 1, right? 5/5 is just 1. So here we multiply by x over x. And here we multiply by 3y over 3y. Here we get something we can add. Okay, and we're going to have to be able to do this. I mean, this is something we assume you can do already with symbols in pre-calculus. Now, in this course, you can spend a little more time talking about it. Pre-calculus, you just got to say, well, if you don't know this, you better learn it. Okay, can't teach you this in pre-calculus. And there's a limit to what we can teach you in this course. Okay, 4 cubed. What's 4 cubed mean? That means times 4 times 4, you should be able to do that easily. 4 times 4, you do in your head, that's 16. 16 times 4, you might need to write it out on paper. Maybe you can do it in your head. Okay. 16 times 4 is 64. Okay. X squared y cubed. What's that? That's something I didn't leave myself nothing to write. Okay, x squared y cubed is x squared y times x squared y times x squared y. Okay. What's that equal? Well, because of commutative and associative laws, we can change the order of a bunch of things. If you've got a string of things that are all been multiplied, we can do it in any order. Okay. So we could write this as x squared times x squared times x squared times y times y times y. Okay. Now what's x squared times x squared times x squared? Well, that's going to equal x squared is just x times x. That's what it means. Break it down to what it means. And this clearly tells us that this is x to the 6th y cubed. Now, the laws of exponents are really easy to confuse, and most people do confuse them. And at one point or another, as I answered these papers, I think most people did confuse them at one point or another. Come down to here, we see exactly what I mean. Okay. Some people tell me that x squared times x cubed is x to the sixth. Okay. Now, if it was x squared cubed, it would be x to the sixth, because what we've got here is actually an x squared and x squared and an x squared. When we cube it, we do get an x to the sixth, right? That's x to the second power raised to the third power. And it's easy to confuse that rule with a rule for when we multiply the same base. So if we break this down to what it means, we've got this is x times y, this is x times x times y times y. Okay. Sitting in the back, you might have a little trouble reading that. We'll just write this out, write all the x's, write all the y's. And then it becomes clear that this is x times x times x times x times x. There are 5 of them, 2 here, 3 here. We see the 2 here, we see the 3 here. And that's x to the fifth times y squared. Okay. Now everything here is elementary algebra, not even intermediate algebra. Okay. Make sure your algebra is up to the task. And if you need to review some algebra, well, we really can't do that in this course. Because in this course, let me talk about the course a little bit before we go on. We hustle like crazy to stay ahead of your pre-calculus class. Okay, because it's better to learn it with an easier version of an assignment that's much like the one you're going to get in pre-calculus. So that when you get to it in pre-calculus, you already know something about it. So you're not sitting there in class, not understanding anything that's being said. Okay. Or not understanding as well as you could. That makes sense? So another thing about this class is it's kind of front loaded. We hustle like crazy for about 3 or 4 weeks, and then things ease off a little bit. Unfortunately, a lot of students just fall out of the class because of the pace. But there's no other way that I can think of that works as well. I mean, you could come in here and say, I have this problem with pre-calculus, and I have this problem, and I have this problem. We can address those problems. It's too late. You've already not understood the lecture. You've already not understood the class. Okay? So we make sure we understand something about the situation when you come in this class. So when you go into pre-calculus, you got some preparation. So you're going to have probably at least 5 assignments a week in here. There'll be easier versions of what you're going to have to do in your pre-calculus. So you get your feet wet so you can understand what's going on in pre-calculus. Okay. Okay. Now come back here. 2 to the negative third. Nobody, I don't think anybody got this. 20 rules of exponents. You're supposed to learn this in elementary algebra. Sometimes even in pre-algebra, but nobody does. Okay. I very rarely get somebody who knows what a negative exponent means. 2 to the negative third is 1 over 2 to the third. That's what a negative exponent is. No negative over here. You took care of the negative by flipping this thing. Okay. Now there's a reason for that. What's x to the negative third times x to the negative third? Well, one way of writing that out, you have a rule of exponents. Okay, now the rule of exponents is back up here. One rule is x to the a times x to the b equals x to the a plus b. Be careful note of that. And you probably ought to flip through the video, okay? You know, just flip through it and see what's going on and see, okay, I understood that, I understood that. I said, take another look at this. Okay? And I better really make myself a note of this because from this day forward, you need to know these rules. Okay. So x to the a times x to the b is x to the a plus b. You should know why. Because down here we have like x squared times x cubed, right? Why does that come out x to the 2 plus 3? Because when we write this out, there are 2 x's here and 3 x's here. Gives you a total of 5 x's. That goes there. Okay. Gives you a total of 5 x's. Oh, you know what? I missed one of my y's here, didn't I? Why didn't everybody jump up and down and tell me? Okay. There's a y here, there's a y squared here. So you got a y and a y times a y. That should have been x to the 5th y cubed. Now here's your rule. If you memorize the rule, you'll know what to do. X squared times x cubed is x to the 5th. If you understand why it's x to the 5th, then you're not going to mess up the rule. Because this rule looks a whole lot like the rule x to the a to the b, which is x to the ab. You multiply the exponent. And that's essentially what we did here. We had an x squared that was cubed and a y that's cubed. Okay. When we wrote this out, we saw we had 3x squared. That's x squared to the 3rd. That's not x to the 5th. There are 6 of them. So there's a very simple reason for this rule and this rule. Unfortunately, our curriculum tends to teach people to memorize rules rather than understand them, which leads to need for support. Okay, and the extensive failure rate in pre-calculus that we're trying to avoid in this course. Okay, I want to avoid it for you. Okay. Okay, so we have these rules now. If we apply this rule to this, because we have x to the a times x to the b, right? That's x to the negative 3 plus 3, which is x to the 0. Another thing should have been drilled into you, but most people don't know it. What's x to the 0? Somebody want to tell me, show me with their fingers, whatever? Yeah, a lot of people going to say it's 0. But you're right, it's 1. Okay? X to the 0 has to be 1 to make all the other rules are consistent. Okay. Another way of writing this okay, using definition of a negative exponent, x to the negative 3 is 1 over x cubed. That's multiplied by x cubed, right? Now, it helps to see this is a fraction. It helps to express this as a fraction, which could be x cubed over 1. I think we're all familiar with that. It's not really true. And then we multiply the numerators, that's x cubed, and denominator is x cubed. That's 1. Okay. So right there is what I'm talking about consistency. If x to the 0 wasn't 1, we'd have a big problem. If x to the 0 was 0, we get 0 doing it this way, and we get 1 doing it this way. And that's not going to work. The whole foundation of mathematics. Okay. Now x times y squared plus y cubed. This uses distributive law, multiplication over addition. This is x times y squared plus x times y cubed.
Yeah.
Or just xy squared plus xy cubed. Okay. Now, distributive law is another point of confusion, and I saw a lot of errors using the distributive law. So I'm going to move this one. And distributive law applies in all three of those cases. A plus B times 2A minus 3B. Well, just like what we did over here, if you multiply x times y squared and x times y cubed and add them, you get this. Incidentally, that doesn't give you x y to the fifth. I think I saw that in a few tables. And you can't combine it, unlike powers. And for reasons that I could explain, but don't go into that much detail. Okay, so we have this expression, a plus b times 2a minus 3b. Well, just kind of imitating what we did here, we're going to say, okay, well, that's a plus b times 2a minus a plus b times 3b. That's a distributive law. Distributive law plus multiplication over addition. A plus b times 2a is a times 2a plus b times 2a. And a plus b times 3b this. So this is 2a squared plus 2ab minus 3ab minus 3b squared. Yeah, there are a couple of details here with minus sign and stuff, but the point is, this is a distributive law. And if you don't apply the distributive law, you're doing your mathematics by superstition. Okay? Superstition is not a good way to do mathematics. You got the rules. You got the distributive law. Okay? And the distributive law said this. Okay, and you got to know that. You really run into problems in pre-calculus if you don't. So a plus b That means A plus B times A plus B. Means you multiply A by A plus B, and then add that to B times A plus B. And it gives you this. Of course, AB and BA are the same thing. So we got 2AB. Then we got these two. It's not A squared plus B squared, but most people want to do that. It looks like it ought to be, but you don't do mathematics by what it looks like. What it looks like kind of guides you, but you check it against the rules. Okay, it looks like that ought to be A squared plus B squared. Yeah, A plus B squared should be A squared plus B squared. I think I saw that more than one paper. Okay, it's not. You have to write out what it means and apply the rules that are completely consistent. Okay. Now, factor x squared plus 5x plus 6. That's x plus 2 times x plus 3. Okay. Now you're probably taught to do something like this. But I saw little loops going in the wrong place in some papers, okay? Among the variety of mistakes I saw of these really elementary, maybe bordering on intermediate algebra questions, okay? So you want to be sure that some of you might not have had a math course for several years, okay? There are people in here that look almost as old as I am. Okay, nobody's that old. Okay, I'm almost 40. Okay, be sure for the next week or so that your math, your algebra is up to this course and the pre-calculus course. If it isn't, you can still, a little bit late, get into an MDE 60 course, which teaches you elementary and intermediate algebra. Okay? If it turns out that you think you're going to need that, that course meets same time this one does, but on Monday and Wednesday. If you think that's a possibility or a good possibility that you're going to need that instead of this, and that course worked great. I had a great, absolutely great section last year. Okay, half the class did so well that I said, okay, I'll approve you to take pre-calculus without the MDE 61, even though if you start an MDE 60, you're supposed to go 61 and then end the calculus. Okay, supposed to do this course with the calculus. Some people did so well. I said that's not necessary. Other people did well. I said, leave it up to you. If you want me to approve it, I will. But you might want to consider taking the 61. Okay. And some people, I said, you passed this. Okay. I think you're ready to do the 61 and 161. You're going to need the 61. So there are kind of 3 levels. And, I've got people from that class and various classes. Not as many as I'd like, but it's a great group. Love that class. Okay. Hopefully, group will be as good this time. So I guess my advice there is if this course loses you and your pre-calculus loses you in the next week, probably ought to consider the MD 60, which means if you think that might happen, it'd be a good idea to rearrange your schedule if necessary, so you have that time on Monday and Wednesday. Now, the other thing is, I post videos from that class for you. You know, if you look down the announcement, you see the MDE 60 videos. You'll see the MDE. Sorry, if you're in this class, this is 61. Okay. You see, if you look at your announcement, you see MDE 60 videos. Okay, those are the videos we did last term right now. They're up there. Okay, the ones we do this term will be up there. So you have those for reference. So decide how you want to go, or how you want to proceed. What I see, if I look at the general status of the class right now, I see most people have the rhythm, but not the music. Kind of know what the rules are. You kind of, but you must apply them like you do this when you should do this, and you do this when you should do this. Okay. And the distributive law, you know, that's got to be second nature. But it's been a while since you had math. You didn't quite have it. Well, you're going to get plenty of practice. Just be sure you follow this. Okay. So that's not to discourage anybody. It's just to make sure you're in the right place at the right time. I think most are in the right place. Okay. And we'll see over the next couple of classes how that's going. Okay. Now, that's pretty much all I have to say today, except that there is an assignment. You're going to have to look at the My Open Math and do the assignments, okay? A lot of times, what we're doing, I'm not going to talk too much about it before you get to homework because the My Open Math has videos, and they're very good. And particularly like the style of them. That's the style they use, but the content is good. Okay, it's well delivered. So, you know, it's helpful with those videos if the class can go too fast. You know, you can lose track. I always, you know, my classes, I always started thinking about things, and when I stopped thinking about them, they passed me by. Okay, I always had to dig it out of the textbook. That's pretty good at that. But you know, some people have their own mental process that doesn't work well with a lecture. Okay. The advantage to videos is you can pause them so they don't ever lose you. I mean, they might still lose you if it's a really tough thing. Okay. But you can pause it and go back and look again. Right. I also advise that when you're viewing the videos, you take notes because you're better off active than passive. Fair enough? Okay, see if you have any more questions.